In this 13.2 video, we're going to be verifying trig identities. So we already introduced them as being these equations or formulas that are true no matter what value of theta you plug in. So we're going to make claims that some of these other expressions are in fact trigonometric identities, and then we're going to verify them. And there are two different ways that we can verify them. First way is to transform just one side of an equation, So let me give you these two steps that we're going to be working with. So step one, simplify one side of an equation until the two sides are the same. That's the basic theory behind this. So simplify one side until the two sides are the same. Simplify one side until the two sides are the same. The second one isn't really a step so much as a tip. My tip for you is to work with the more complicated side of the equation. Okay, so start with the more complicated side. And then that's the side you want to transform. Okay, so this first example, we're going to verify that this is true, which basically means we want to prove that no matter what you plug in for theta, this is going to be a true statement. So we want to simplify one side until it looks like the other, starting with the more complicated side. So of course, the more complicated side is this one right here. The main technique that you're going to be using is one we learned about in the last set of notes, which is to write everything you can in terms of sine and cosine. So we're going to be using some of the identities that we learned in the last video as well. So cosecant. The way we can write cosecant in terms of either sine or cosine is by using our reciprocal identity. Okay, so we can write that as 1 over sine of theta. So that's just cosecant right here. We wrote it as 1 over sine of theta. Times, the next one is cosine. Cosine already is cosine, which means we don't have to do anything else to it. We're just going to leave it just the way it is. And then tangent. Tangent, we can use one of our quotient identities, which we had on the first page yesterday, and we can write that tangent is equal to sine over cosine. Okay, so we're just working on, we started with the more complicated side, we're working on simplifying it down. So what you can see here is, if we think of this as like cosine over 1, we've got multiple different pieces where we have the same thing in the numerator and denominator. So like these cosines would cancel each other out, and these sines would cancel each other out. So you multiply all this out, and that is just equal to 1, which is what it was supposed to equal to. So that means that 1 is in fact equal to 1, and you have verified that that is in fact true. Okay, we're going to look at something really similar with example number 2. This is set up as a standardized test question. Basically what we're going to do here is simplify the left-hand side and see which of these we can get it to equal. Okay, so cosecant divided by cosine. Remember, our main technique is to get everything in terms of either sine or cosine. Okay, so cosecant is 1 over sine, and then divide that by cosine, which remember, we can just leave that as cosine, and then minus tangent, which is sine over cosine. Okay, so both of these things are over a denominator of cosine. So let's start with this left-hand piece right here. So this piece is 1 over sine, and then we divided it by cosine. So I'm going to rewrite that as multiplying by the reciprocal. So we're going to take this, and then instead of dividing it by cosine, we're going to multiply by its reciprocal. So that gives us 1 over sine times cosine. And then we're going to subtract this quantity right here. So currently this only has cosine as a denominator. This needs sine times cosine. So I'm going to multiply this by sine over sine. Okay, so multiply these out. I have sine times sine, which is sine squared, and then over sine times cosine. So you can see now that the denominators are the same. So I have 1 minus sine squared, which, according to some of yesterday's stuff, remember, 1 minus sine squared is equal to cosine squared, and that comes from this first Pythagorean identity. Okay, so 1 minus sine squared is equal to cosine squared, and then over sine times cosine. And I'm going to cancel out one of these copies of cosine, so it's just cosine now, not cosine squared, and I cancel this out. Finally, I am left with cosine over sine, one copy of cosine over the only copy of sine. And cosine over sine, according to one of our quotient identities, is cotangent. So a lot of simplifying can happen with this trig stuff. All right, so last thing we're going to be looking at in 13.2 is situations in which you'd have to transform both sides of the equation in order to get them equal to each other. That's what we're going to be dealing with here. We basically just want to manipulate until we get both of the sides to be equal. So here's some different techniques that you could use. It's a lot of the same stuff that you would use when you're simplifying algebraic expressions. So let me run you through that. So we might be doing some substituting with some of the trig identities that we learned in the last video. We might be doing some factoring or some multiplying, factoring, foiling, things like that. You might have to multiply top and bottom by the same trig expression, sort of like a fancy one sort of thing. Writing each side in terms of sine and cosine only, we've been doing that for a while now. And then properties of equality, keep in mind that these don't work the same way as like normal functions do. They're not functions, they're identities. So you can't multiply both sides or add both sides or whatever. So like that last one is an important thing to keep in mind. So with example 3, we're verifying. We're going to simplify both sides. Okay, so I would start with this technique right here. Write everything you can in terms of sine and cosine, and then we're going to keep simplifying to see if we can get them to equal each other. So start with cosecant. That's 1 over sine plus, and then secant is 1 over cosine equals. And then what I'm going to do here, this is kind of an unusual one. I have 1 plus cotangent. So I'm going to split both of these up. So like I'm going to put 1 over cosine, split that up, and then plus cotangent over cosine. I'm going to split that up. Okay, so keep on simplifying. So I have 1 over sine and then plus 1 over cosine. I'm still working on the first step where I get everything in terms of sine and cosine. Equals, and I have 1 over cosine plus, now I still need to transform this. So cotangent, remember, is equal to cosine over sine. And then that is divided by cosine. Okay, so I just want to simplify this part right here. Okay, so I have cosine over sine. And then instead of dividing it by cosine like this, remember it can multiply by the reciprocal. Whoops, sorry, this should be sine. So this right here, cosine over sine, is cosine over sine right here. And then instead of dividing by cosine, I'm multiplying by the reciprocal. And what happens there is the cosines will cancel. So this right here just ends up being 1 over sine. So I can rewrite that. Plus, so after I simplified this up, I ended up with 1 over sine. And we are actually ready to stop here. This is in fact verified. I've got the exact same thing on both sides. Remember, the order for addition doesn't matter. I have 1 over sine plus 1 over cosine. That means the two sides are equal. That means we have verified the identity.